Welcome back. This is lesson 8. I want to use it to revisit what we've described as type 2 maths. I want to spend time developing ideas that I've already introduced. This type of maths is what people usually associate with the word mathematics. And to a certain extent, type 1 and type 3 can be viewed as having supporting roles. In an earlier lesson, I wrote 2 plus 1 equals 3. And I followed that by 2 is equal to 3 minus 1. Both of these mathematical statements refer to the same relationship, but it is being viewed from different perspectives. The first, 2 plus 1 equals 3, is where does adding 1 lead us? And the second, 2 equals 3 minus 1, is how do we get back to 2? So in mathematics, we can rewrite a relationship depending upon what our interest is. So in more detail, here are those two equations again. The first, start with 2, change it by adding 1, and you will generate this new value, 3. In the second case, 3 is changed by subtracting 1, and that leads us back to 2. The students who do best at maths are the ones who can read more detail into what they are seeing. They are the ones who see this when presented with this. In maths, we can read equations from either the left side and then the right, or the right side, then the left. Notice that we always read from left to right, but we begin on either side of the equal sign. So here, reading from left to right, 2 plus 1 equals 3. If I want to begin reading on the right-hand side, 3 minus 1 equals 2. I read this from left to right and then go back to the left-hand side of the equal sign. Now, there are other ways of referring to this factual relationship, but I want to focus on these two. Can you see that we are in a way reversing direction and at the same time reversing the processing? This notion of reversing is very common in type 2 maths, where we deal with incomplete statements such as a missing value plus 1 gives 3. So something is missing in the equation and our task is to find its value. Now obviously the missing value is 2. For many students it is just obvious. What they don't realise is the brain is subconsciously processing the statement. Now I want to make sure you appreciate that all processing in maths must be done consciously and expressed formally so that it is always accurate. That is important. Your processing must be done consciously. In mathematics, we practice techniques in order to improve skills by ignoring practical situations. We just process the values that we would obtain in a practical situation. That keeps it simple. So if we see a missing value plus 1 gives 3, we write the missing value must be 3 minus 1. And we can draw the conclusion the missing value is 2. So we got from what was presented to us to a conclusion by processing. It's very simple. Nobody has trouble with this. But actually, it is where mathematics starts to break down for a lot of students. They say, I don't need to write it formally, I can just do it in my head. I already know the answer. It's a waste of time writing all that. These are comments which usually indicate a student is weak and will make poor progress. What they don't realise is the formal presentation is what allows the logic to be transferred to other realms. And the power of mathematics is in the transferability of the logic. That is important. The power of mathematics is in the transferability of the logic, and that demands formality. It has nothing to do with the numbers. The numbers are not even necessary. We could have an equation like this. A missing value has something added and generates a new value. Each symbol could represent the value of something in a real-life situation. But we don't know what the values are. But it is true that the missing number is whatever this unknown quantity was minus whatever this unknown quantity was. So there are no numbers, but the logic is correct. And it's the same logic we have used previously. But here we don't even know what the symbols represent. We are expressing the logic, not worrying about the numbers. So here we have a reverse processing technique which helps us get an unknown value. It's called solving in mathematics. Step 1, look at the statement supplied and identify the missing component. Step 2, rewrite the statement but shift the known value away from the missing part. We move it to the other side of the equal sign. Step 3, reverse its processing, and that will lead to a conclusion. Then, if necessary, repeat steps 2 and 3 if you haven't isolated the unknown. So what if we're given a missing number is doubled to give 10? We would write the missing number is 10 divided by 2. And we would conclude the missing number was 5. We have used a number given in the original statement, but its processing was reversed in order to generate the conclusion. So when we move the 2 so that it's now processing the 10, we reverse the original multiplication by using division. In formal mathematics, we don't say reverse, we use the term inverse. The inverse process undoes the original process. A more difficult example. If you double a number and then add 1, you get 11. What was the number? Now take a moment and generate your answer. This question is not intended to be difficult. Remember, we're identifying processing steps. Okay, here's a formal solution. We were given double a number and then add 1 gets you 11. So in order to process that, we remove the 1. When it goes to the other side of the equal sign and joins the 11, we reverse its process. So addition becomes subtraction, and we can draw a conclusion. Double the missing number is 10. Now, have we finished? And the answer is obviously no. So we repeat that process. We are beginning with double the missing number as 10. We shift the 2. We reverse its process. So multiplication becomes division. 10 divided by 2 is 5. So this conclusion, the missing number is 5. Have we finished? Yes, we have. The missing quantity has been isolated, so we stop the processing. We have used a basic 3-step process twice in order to get from a statement which has a missing number in it to a conclusion about the value of that missing number. Now, your own logic was probably very similar to the solution I gave you. The structure of the problem is very obvious, and it invites you to undo the complications. So note that the technique has 3 components. Examine the given equation, change it, and draw a conclusion. They are always used in the same order, and they always lead to success. Examine the given equation, change it, and draw a conclusion. So here we have it. Examine the given equation, change it, draw a conclusion. And keep that process recycling until you get to the simplest possible statement. And that is what we call a solution or an answer. Oscar, stop snoring. Now, this is the most important processing skill needed for ongoing success in mathematics. Once it's a reflex response, mathematics becomes much easier. And it's a skill you will call on many, many times as you go through any school program about mathematics. Now, we covered a bit of work there. I hope it's consolidated some of your ideas, and you can now apply that logic accurately and quickly. We'll build on that in the next lesson. See you then.